Welcome to my talk on demystifying technical debt. So one of the things I started wondering is what technical debt is. It's one of those things that people say a lot. However, I usually don't find any really nice explanation on what it is. Usually they kind of imply it's some sort of monster that eventually will eat all your code base if you don't take care of it. But I think it's more interesting than that, and you shouldn't be really afraid of it. Before we get to anything, let's start thinking about a simple example. So why is considered this old piece of example code a debt? Maybe some people don't think of it as such, but the other question is, why do we need to pay it off in the first place? Or who lent this debt to us in the first place? How much do we actually owe, or how can I pay it off? Or can we lend some of our things to other people so that we gain interest on it? These are kind of things that started making me wonder whether it's a good metaphor in the first place. So let's take a step back. What are the things that we understand or that are easier to grasp than this metaphor? When we talk about software, one of the things that we are worried about is quality and mistakes. Whether the software is fit for purpose. Do the people using the software actually get what they wanted? Or how usable is it? The other thing is, does it have any bugs? Or will it fail on the first try? Or maybe it's not as secure as it should be. Or maybe it's not as flexible or efficient. And maybe it's not that good to maintain. When we're talking about technical debt, usually we mean the maintainability part. So the question is, what is maintainability? One thing we can consider is effort. How much do we have to do work to make a change in the code base? For example, we may want to consider how much effort is to modify code when we want to maybe rename types or add new types, maybe modify a method, or move packages around, or rename packages, or create new ones, or so. Maybe there's things to do with testing, how difficult it is to test the software or write new tests. Or modules. How is it composed? How do different parts of the system work together? Maybe we need to update documentation. And of course there's more, but the idea is that there's some amount of physical effort we need to do when we want to make a modification in the code base. It doesn't need to be code per se, but it's usually some sort of artifact. The other part of is in understanding. There's some mental capacity that goes into understanding the code structure as it is and architecture of the system. How does this system work in our heads? That doesn't always match up with what we have in code. Or how well we know the product itself. Do we actually know what it should be doing or how it should be doing? Or how do we understand whether it gives value to the end user? So there's some part of mental effort that we are doing while we're modifying code to match what we wanted to do in the future. There's also effort in communication. We need to communicate ideas to other developers, maybe the product manager or the end user. So there's all this effort that goes into maintaining code bases. While there's this effort, we don't consider that as a technical debt by itself. However, we can notice changes in this effort. So if we change code over time, we get more code. It's rarely when we remove features or functionality. There's more user interface to consider and features interacting with each other. There's also effort increase in understanding the project, because if the project is larger, we know smaller percentage of the whole project. However, we do gain better understanding of the business. And unfortunately, this understanding also decreases when people change. We tend to forget things. People go to new places to work, and a lot of this information is not written down but stuck in people's head. Of course, communication is so vague that it usually increases with company growth and decreases by putting in place clearer processes how things work, but it's less related to directly to the code base itself or maintaining the code base. So overall, we can see that this change in effort usually is positive. So we must do more work to modify or maintain the code base. So you might think that this change in effort, that's the technical debt that we are all thinking of. However, there's a good question to ask. When you don't use a code and it's just something on a paper, does it accumulate technical debt? And the question is, why not? Why is this piece of paper accumulating? Nobody's changing it. There's no people churn. So the question is, what's changing? One of the things that we know while developing software is that we make mistakes. It's inevitable. And we notice these mistakes. And you might now wonder, like, what is a mistake in itself? So there's this difference between what we see and what we expect. That's kind of maybe too obvious, but there's a more interesting aspect of with effort, because we do notice that there's this thing we perceive as how much effort we are putting into the work to maintain something and how it could be, like what we expect it to be. So we can draw it on a graph. We have this perceived effort, like how do we perceive how much work we need to do to make something work or add a new feature. So this perceived effort, of course, goes up when we add new features or we have more code to work with. But also, it decreases when we understand things better, because we understand how to make the change without having to read a lot of documentation. So maybe the amount of hours needed to complete the work is lessened. But also, when we improve the code or communication or any of the effort parts, we decrease the effort we need to do, or the perceived effort. There's also this thing of ideal effort. Is how does that change? One of the interesting aspects is that when we notice mistakes, then what the thing we perceive or how it could be improves. So we know how to make things better. So this ideal effort or how much work we needed to do to make changes in the code base goes down. Or if we learn new things, we also understand that, oh, I could have done that simple method better. Or if we forget how to do things, then of course, like this will go back up. So the question is, what is this difference between them? I think this is the thing that when we are talking about technical debt, this is the most important thing. This notice the potential improvement, like how much we can improve the system. So you could say that it's the difference. Not everybody agrees on the definition, and I'm given up on finding consensus on definitions with programmers, but I think it's a useful way of thinking of it. If you don't like this definition, then replace it with potential improvement in the system. There are interesting aspects of this notion. If you get a breakthrough in some sort of way, for example, Go language, as when you found out how easy it is to cross-compile, then the technical debt for other systems that didn't do that way grew larger, as weird as it is. Similarly, when a new framework like React came out, then people immediately saw that, oh, some things can be much easier to implement. So the existing system technical debt grew because we learned new ways how to do things better as a community. The other side of technical debt is often like trying to borrow this, maintenance cost. So we make a intentionally poorer choice how to fix things, however, or how to implement things, whereas we know that there could be a better way for different reasons. It's not necessarily bad, but you must understand that there's if you let it grow for too long, then of course you get problems. The other side is you can think of also quality debt, like what would it mean? What would it mean to have a security debt? One important thing is that when you increase quality, sometimes the effort to maintain the code goes also up. For example, if you disregard any security, which you should never do, then the maintenance cost is usually lower than trying to verify that your software is secure. So there's a balancing act between effort and quality. Now, I gave this as an absolute value. However, this effort, or the perceived effort and the ideal effort, they aren't really absolute values. And also, they aren't that precise either. Like, what does it mean to have average effort? Average for the company, average for the community, or average for a beginner? It will depend on your particular needs, which one you want to use. However, it's useful to also think, how does my perceived or ideals differ from the average of the company, let's say. So there's this bias in this effort evaluation. We could be positively biased, so we think that the average effort is lower. So hype is one of those good things that happens. So if you really like something, then you perceive it as taking less effort because you're having fun and you don't notice as much time has passed. Similarly, things we know we perceive to be taking less effort because we know them. Like it will take less effort because other people who don't know it will take longer. That's kind of slightly obvious, but... And of course, tools knowing very well will make our bias positive. But we also have this negative bias. If we really like some other language, then using Go might feel like it's really slow and counterproductive, not necessarily because the effort to write Go code is difficult, but because we don't understand how to write Go code. This goes for any language. One interesting thing is that flaky behavior also gives this negative bias. If something isn't happening consistently, then we feel like it's worse than it actually is. So a flaky test that happens once in a month may seem really annoying at the moment you see it. But realistically, it maybe waste 5 minutes per day or for a month. So not understanding, of course, also has negative bias. So if we are completely lost when using something, then it makes you feel like, oh, this is really slow way to do things. And of course, noticing things that don't work as well makes our bias worse. And for some reason, we also perceive all things as requiring more effort to use. It is true to some degree. However, if you think about how often you learn a new framework, you could learn an old framework at the same rate. So it's weird to think of old things as taking more effort. Obviously, there is some truth to this because the community has evolved to some degree. There's also the question of how wide this bias could be. If you know nothing about a system or a language or a code base, then you might widely misjudge how much effort actually is needed to maintain it. So if you go into a new code base, maybe it seems hard to maintain because you haven't familiarized how it has been built, not necessarily because the code is bad. So as I mentioned, the technical debt metaphor has been widely used in different ways. The source of it is, of course, Ward Cunningham. And initially it was just about the business. Like, you don't know everything about the business, and over time, as you learn more about the business, the technical depth, how you reflect that in code, increases. So you might spend more time in trying to make it look like the business. So now you might ask, like, okay, technical depth, yeah, no, I roughly get the idea. What can you do about it? The first thing people want to do is rewrite everything. The issue with rewriting everything is that it's really difficult to rewrite large pieces of software. There are many places that have worked really well, and there are places that don't work as well. And it's interesting to note that the places that aren't as perfect as they could be are more visible than the things that work really well. And often when you start to rewrite things, you tend to ignore the things that worked well in the previous system and break them during rewriting. And of course, the larger change, the more mistakes you'll get. So avoid it or do it as a last resort. Things that do help is continuous learning. Learn, read, experiment, find new ways of solving problems. Ask for help or to review your code. Maybe ask, if you're a company, ask for a consultant to look over your code base and find things that could be improved and to teach the people. It doesn't need to be a long-term deal. It could be just a week and they could drastically improve your code base. One interesting thing here is that learning about things increases this technical depth because you know new ways of improving the system, however the code hasn't improved. But what it does, it prevents from this increase in effort as rapid rate as if you didn't know this information in the first place. One really useful thing is code reviews. Automate your linting to tell you things that could be improved. There are plenty of tools, static check, Golang, CI, lint, revive. And one thing to strive for is to make every commit 1% better than your previous one. Maybe it's 1% faster to write, maybe it's 1% higher quality. It means that over time you get better and better making code changes such that your technical depth slowly doesn't increase as fast or starts to decrease if you also improve the code around it. Of course, be wary that if you try to combine a lot of changes into one commit, then it will be hard to review. Strive for this gradual improvement over large refactoring. So there's been some research by SmartBear suggesting 400 lines of code per change. So that's the limit when this defect rate discovery starts to decrease rapidly. And it's useful to think whether two similar commits would make it difficult to maintain. It helps to ground your or notice things that might go wrong in the future. You can also think about maintenance and doing a regular review on the code base, like for things that you might have missed, to prevent new things to be added that contain the same mistakes. Also make notes of what causes the actual effort. Sometimes a single video describing the whole system for the developing team can be much more effective than a large refactor. Isolate problem areas. There's a pattern called anti-corruption layer that helps to isolate things that aren't as good, so you can later replace them with better things. And notice common problems in your code bases. That way you might find them in code reviews, or you could even write the custom linting for it. And finally, acceptance. You will make mistakes. Technical depth, as you see, there's always things you can improve, and sometimes they are even conflicting improvements. So improvement in performance could decrease the quality of the code or readability. And not everything needs to be fixed. You don't need to rewrite your scripts in Haskell for the purity. And choose your battles. Your time is limited, and understand what would help the most with reducing the effort to maintain the code base. So, technical depth isn't a monster, it's just the realization that you could do better.